This is part 2 of video 2.6.2. It does pick up where I left off in the previous part. So we're in the middle of graphing this, and we're trying to, we plugged in a bunch of points, all these points that you see over here, and now we're going to plot those points in order to get the best picture of our graph. We already had our intercepts that are in red, so let's continue in red. -2, -1.4 would be down here. 1, 4 is up here. And then 2, 9 is way up here somewhere. So it looks like I have enough to draw a sketch. Something along those lines there. Okay. I probably would use my calculator to make sure I understand what the curve looks like. This actually does get quite straight, and it's going to get really close to that green asymptote. So remember, the slant and horizontal asymptotes really only work when x goes off to infinity or negative infinity. So this is x going to negative infinity. It looks like we're following that green line. Okay? When x gets really close to 3 from the left, we're going to shoot up into positive infinity. Now we take a look at the right-hand side of the graph. We have these points to add. 4, -5, way down there. And then 6 was up at 2.3 already. So that's going to be up here somewhere. So we have kind of this graph going here. So once again, the graph will get exceedingly close to these asymptotes that we had originally graphed, but they are, so it's going to get really close to this asymptote, and it's going to get really close to this asymptote, but it will not touch them as we shoot in those directions. Okay? That is a complete graph, as beautiful as it is. You are going to have to plug in points and make sure that you get a nice sketch. Okay? And you should be able to do this without a calculator for the most part. Let's take a look at one more example, and then I'll show you your checkpoints. So we're going to take a look at this example because it has an interesting hole. So we have, remember, we want to keep an eye on our steps. We're going to find our intercepts, we're going to find our asymptotes, and we're going to find some more points to make a complete graph. So our intercepts, remember, we're going to plug in 0, and we're going to figure out when the function is 0. Those are our 2 steps to finding our intercepts. So we're going to plug in 0. That's going to be an easy case. 0, 0, 0, 0. Looks like on the top I'll get -14. On the bottom I'll get 12. So the 0 is at -1.16 repeating. So there's my function at x equal to 0. So I have 1 point. Now I'm going to figure out when the function is 0. So remember, the function being 0 has everything to do with the factored form. Okay, this is also going to get me towards my intercepts. So I need to factor the numerator. The denominator is already factored, so I want to leave it that way. I'm peeking for, are there common factors like the denominator? So I want to check. Try those first, because that may mean a whole. In this case, it does work out that x plus 2 times x minus 7 will give me my numerator. So that means that at 2, there is a whole. At -2, excuse me. It also means that if I can cancel those out, I'm really just graphing this graph with the small exception that at -2, I'm going to have a whole. So I'm just going to consider this graph here on out. Think about it. If I plugged in 0, I should still get the same value if I plug in 0 here. I should still get -1.16 after plugging in 0 into this simplified function. Okay? Now I can easily ask the question on when the function equals 0 to figure out my y-intercepts. And to do that, I simply look at my numerator. I don't want to look at my denominator. I want to look at my numerator, because when this is 0, it's because the numerator is 0. So it looks like f of 7 gives me 0. Before I simplified it, I would have seen that x equal to 2, -2, would have also given me a 0. But because it gave me 0 in the denominator as well, it's an undefined moment. It's either an asymptote or a whole because it gave me 0 in the denominator. So -2 is not a 0 for the function. We do have some asymptotes. We have vertical asymptotes that occur when the denominator is 0, because that means x cannot be that number. So we have a vertical asymptote that we can see here at -6. So at -6, I'm going to draw in my asymptote for the function. So some of you have already asked, well, what do we do if there's a hole? We know there's a hole, we see something canceling, what do we do? Well, what we do is we plug in the number, in this case, okay, so we have our asymptote -6, x equals -6. We plug in the number x equals -2 to see what the hole will be. But we don't plug it into the original function, we plug it into our simplified function that you see in that red box there. So I'm going to take this function here and I'm going to plug in -2. Okay, I'm going to plug in -2. So I'm putting in -2 and -2, and it looks like I get -14, -9 on top. -9 on top. And I get -2 here would give me 4 on the bottom. So it looks like my hole will be at -2.25 for y. So my hole is that x equals -2, y equals -2.25. Okay? X equals -2, y equals -2.25. So somewhere in there. So I'm going to be drawing an open hole there. And apparently my graph is going to come through that point, but it's not going to go through the point exactly. It's going to go over, basically, and cross over the point and skip that point. So I have my axes. I do need to graph my intercept. So remember, my other intercept was at 7, 0. Okay, I need my y-intercept at 0, -1.16. This is all starting to fit. I'm starting to see a graph here. I'm starting to see a graph that might look something like this. Okay. The next thing that I want to test for is any horizontal asymptotes. Okay. You can go back to your original function or stick with your simplified. It will tell you the horizontal asymptotes either way. Let's see, the degree is identical. They're both going to be a squared. This will create an x squared as well. So now what I do is I find the ratio between the coefficients. The top has 1x squared and the bottom will have 1x squared when I multiply those two terms. So my ratio is 1 to 1. And that means that my horizontal asymptote will be at 1. So let's call, let's draw in that line at 1. This is my horizontal asymptote. So this graph, this original function that we had here, will never be bigger than 1. Okay, this will never be crossing, it'll never be bigger than 1 when x gets to infinity. Now when x is -infinity, maybe it'll be bigger than 1 then. We're not sure. We'll have to look. So I have a graph that I can do. I can do this graph right here. I have plenty of points there. If I wanted to be sure, I could plug in like -5, or I could plug in 3 to make sure that it looks like this, but I can pretty much make the guess that it's going to look like this. The next one I want to graph is some stuff over here to the left. I want to graph some things over here to figure out what they are. So I'm going to graph f of, we'll plug in a couple of points. We'll plug in f -7 and -8. So it looks like when I plug those in, I get -7, 14. So I'm going to be -7. I'm going to be way up here. And then -8, 9, -8, 9 is right in here. So I'm starting to see the picture of my graph. It's going to look something like this. So there's your complete graph. Maybe it wouldn't hurt to plug in -9 as well and see what I get. And it looks like I would get -16 divided by -3, which is about -5. So that makes sense with what I predicted. So -9 would be at +2, 3, 4, 5 point something. So there's another point, just to make sure that I'm right. I know nothing will appear down here. I know nothing will appear down here because I have a, sorry that I erased. I have down here nothing will appear because it's a function. And since I already had my function up here, you can't have anything below it. Same thing in this region. There's nothing that's going to appear up there because it's a function and we already have that red graph below. So you are done when you graph these two pieces. So that's graphing rational functions. So keep those steps in mind, okay? I'll give you some hints on these checkpoints if you got stuck. A couple of hints are, number one is actually just a quadratic with a hole, okay? It's just a quadratic with a hole. So figure out what that quadratic is after simplifying the rational function. The second hint I have for you is that the denominator in number 2 will factor, and it will give you at least 1 0, and therefore it will also give you one moment where it will be undefined. So there will be a vertical asymptote there, and then try to find that slant asymptote. See if you can find the slant asymptote for number 2, the slant asymptote for this one here. Okay, hopefully those hints will help you, and please bring in your questions, and tomorrow we'll practice graphing these functions.